Hello, everybody, and welcome to Solar Roofing Best Practices, where we're going to be addressing solar roofing codes and standards. And those key code books and standards that are going to be discussed here are shown on the screen. We'll be addressing, of course, the National Electric Code, the most recent version of which is 2017, starting to be applied in many parts of the country. We'll be addressing the Fire Code, which might be either the International Fire Code or the NFPA 1 Fire Code, which are pretty comparable to one another as it pertains to the concerns that the solar industry has for the most part. We'll be addressing building codes, which include the International Building Code and Residential Code, but all these codes are disseminated usually into some state level code, such as in California, where we show the California Residential Code book there. And then finally, we'll be addressing several important standards in solar: UL 1703, UL 2703, and UL 1741, as well as guidelines that are established by the National Roofing Contractors Association and the Tile Roofing Institute. So the key topics that we'll be addressing break into the following four categories: code standards, permitting and inspection, and overview. Fire setbacks. Now, we've seen those recently implemented in the Northeast, in Minnesota, and most of the Western United States is following these. Those have recently changed, and we'll be addressing what some of those changes will look like. We'll also address the UL 2703 for rack-mounted PV systems that addresses the bonding and grounding of the modules in the racking system, mechanical loading, as well as fire classification. Finally, we'll end with waterproofing of the roof, some of the common problems, and what the codes and standards require and best practices. So those are the key topics we'll be addressing over the course of the next hour and a half. And I will point out, for those that aren't familiar, there are initiatives underway, most notably the California AB 2188 streamlined permitting process requirement that went into place a few years ago. And part of that is the development of what you see on screen, the Solar Permitting Guidebook, which establishes standard plans and toolkits that make the process of applying for a permit painless in many areas. So this is a standardized process that's worth taking note of. There are other initiatives underway as we speak in other states beyond California, but it's a model for which I anticipate we'll see replicated through much of the country in the coming years to help jurisdictions more easily understand some of the key things they should look for in a solar permit. QuickMount PV is a manufacturer of a broad range of flashed roof attachments and racking systems for roof-mounted PV. We manufacture roof attachments for composition asphalt shingle roof, tile, shake, slate, metal shingle roofs, low slope roofs of many shapes and sizes and flavors. We do have conduit mounts, penetration flashing. Our newest product is the Q-Rail racking system, which is a rail system that works beautifully with the range of roof attachments that we offer. Has three rail sizes: a heavy, standard, and light. The light works well in non-snow areas with lower wind speeds such as California, Arizona. The standard rail would be great in areas with heavy snow loads or heavy wind loads. The heavy rail would be more suitable for ground mounts or possibly roof mounts that would be able to accommodate longer spans because of a heavier structure. They have the rail is available in black and mill finish and has a really neat tool free internal splice. There's no tools needed. You slide it into place. It has a clever a bonding plate in there that will bond one rail to the next with no tools. Fast and easy. There's also an external splice as an option in the event that you might want to position a clamp right where a splice occurs, or if you needed to do a splice in a cantilever area. It comes with these cool Q-click clamps that have integrated grounding, and the clamp engages over a long surface area to prevent any damage to the rail under some over torquing situations. The Q design tool, which is the online design tool developed to support the Q rail system, has some really neat features, including being able to accommodate staggered attachment attachments as pictured on screen here, becoming a standard in many parts of the country. It can also accommodate combination portrait landscape arrays, which are the real world of solar, particularly with the setbacks. It will generate bill of materials and an engineering report. The quick rack rail free system for asphalt shingles has been available for several years. Plenty of information on the Quick Mount website that I would refer you to learn more about that. The newest shingle product is the L-mount, which is a low-cost L-foot mount, which still gives an elevated water seal at an economical price. The E-mount is the largest volume asphalt shingle roof attachment that Quick Mount manufactures. It has a really cool seal system that gets encapsulated in a rectangular aluminum block where when you tighten down on the lag screw on the right to secure the L-foot to the top of the mounting block, that thick rubber washer, which has a stainless steel washer embedded inside of it, will expand in diameter, completely filling that cavity, giving a robust 30+ year life seal. An elevated water seal, so the sealing surface is still 0.7 inches above the flashing plate, so it's a really clever design. The Q-Box is a flash transition box to help you bring your PV cables into the attic space, so it's going to give you that waterproof elevated water seal and easy way to transition from the PV cables on the roof into the attic. The tile replacement mount is available for tile roofs. One of the things that's nice is you get a sturdy, robust standoff integrated into a flashing and a replacement metal tile that replaces the concrete tile, so you can set that one aside and use it to repair any broken tile during the course of the installation. Such a popular option that it's now been expanded to the hook style product, so this tile replacement flashing can essentially be used with any tile hook to replace the concrete tile. You set that tile aside and you can use it for spares elsewhere. All of these products can be easily accessed at the Quick Mount website, just looking for the green free sample button. If you click it, you'll just fill out a form and you'll be able to get a sample so you can evaluate the product in your own hands. You can also check out the podcast titled Solar Roof Talk by either Googling that search term or go to the Quick Mount website and you'll be able to learn more about our popular webcast that addresses a number of topics that are of interest to rooftop PV installers. If you want to have the Quick Mount Mobile Training Center come to your place of business, just contact the sales force. It's been recently upgraded with the new Q-Rail rail-based racking system. My name's Jeff Spies. For 6.5 years, I worked with Quick Mount PV, most recently as their Senior Director of Policy. But recently I've launched a new business venture where I am the president of Planet Plan Sets. We're a provider of residential PV plan sets to contractors. I also serve as secretary for NABCEP, the industry certification organization. I'm on the board of the California Solar and Storage Association, previously known as CalSEA, where I chair the Codes and Standards Committee, and I serve on the UL 2703 Standard Technical Panel, where I lead the task group on bonding and grounding. In my spare time over the past couple of years, I have been engaged as the executive producer of a documentary film that tells the true story about how the PV industry started. It's very entertaining, and we're going to be showing it over the course of the next year or so at major industry events. Hope you can see it. My degree is mechanical engineering. For 30 years, I've been in technical training. I organized the largest technical training conferences in the solar industry. Thousands have attended my web trainings and in-person trainings, do a lot of writing for trade publications and speaking at industry events, but I am a solar fan. I really love the technology and I'm just tickled pink that I can work in an industry that's also my hobby. My own home system had been featured in Solar Pro magazine a few years ago, because we had done some interesting things to adapt the PV system both to the roof and installed one of the first secure power supply inverters, which allows me to get power when the grid's down without even having batteries. So a neat system. This training is available now on demand, which is really nice because 24 hours a day, 7 days a week, you can access this training without having to wait for the next scheduled monthly webinar. Now, we do have the PDF of all these slides easily accessed through our website. Just do a bit of searching. You should be able to find it without too much difficulty. You'll also be emailed the link to download those slides via PDF. And we do have previously recorded webinars hosted as a YouTube video that you can find linked on our website or searching YouTube. You can still ask questions as we go through today's material. It will be sent into our tech support staff, and your answers will come back within 1 business day via email. So you do have the ability to ask questions and get them answered. It won't be immediate, but at least within a single business day, you'll have your response. If you participate for the full webinar, you'll get 1.5 NABCEP continuing education credits. And that's because you get 1 credit for every 1 hour of material completed. So if you complete the full 90 minutes per training, you will be eligible for 1.5 NABCEP credits. It'll be emailed to you within 1 to 2 weeks with the links to download the slides, as well as view previously recorded webinars. As always, check your spam filter. Oftentimes the emails end up there. We do appreciate all the feedback after the presentation is complete. We take it to heart and do our best to improve training webinars in the future. So with that said, we will go ahead and get started with code, standards, certification, and permitting. And this is a interesting range of considerations when we're looking at codes and standards and certification and permitting. Codes and standards, in essence, form the basis of the rule book, and certification and permitting, I should say codes, standards, certification form the rule book. The permitting and inspection is the implementation, and oftentimes where the challenges come into play. So we put this presentation together to help frame the subject in a more understandable way to help contractors prepare themselves for getting through the permitting process with as minimal pain and preserving the best quality over the long run. The challenge is that codes and standards for solar are complicated by the fact that we have multiple trades and skill sets. It's not enough to know electrical. You also have to understand roofing and plumbing and carpentry and IT. So this diversity of skill sets makes it more challenging for solar since it's a relatively new trade. And there is a growing complexity in codes and standards. By nature of the fact that solar has grown quickly, we have seen all sorts of 3, 4-letter acronyms, sometimes 2-letter acronyms become the daily discussion. And this alphabet code of this alphabet soup of code, standards, and industry best practices is growing more complex every year. And I half jokingly say, confusion is the new solar standard. So we created years ago at Quick Mount PV the wheel of accountability, which encapsulates all of those entities that have some say in the manner in which a PV system is designed and installed. And there's 3 basic concepts or basic categories for the slices of the pie that you see here. You have those entities which establish the codes. Now codes are, look at them as law. They are a set of rules that specify the minimum level of safety to protect the public, and they're legally required and enforceable. So being code compliant means you're complying with the law. That's why I always joke or kind of chuckle to myself when somebody says, all my systems are quality, they're all 100% code compliant. And I always laugh and think, well, all you're saying that your systems comply with the law. Gee, I would hope everybody would try to comply with the law. And I know sometimes they're confusing, so it's hard to know if you are complying properly with the law. But that said, being code compliant does not mean that you necessarily have a good performing system. It means that your system is complying with the law at a basic level, minimum level of safety. So nothing, extreme there. Now, standards are voluntary guidelines approved by recognized organizations, often used as the basis for code, an example of which is UL 2703 or UL 1703. These are standards, but they become code required when the language in things like the National Electric Code says your modules must be listed to UL 1703, or your module or your inverters must be listed to UL 1741. Or in the case of UL 2703 bonding and grounding, you must use a listed grounding device, and that is the relevant listing. So in essence, standards become code required because they are called out in the code book. Finally, the most stringent guidelines are best practices. These are guidelines established by subject matter experts intended to improve the long-term performance of the solar system, and in my view, those that aspire to design and install systems that adhere to as many industry best practices as possible will be giving the best value to their customers over the long run, because those are the systems that will have the fewest problems, safety, performance, and otherwise. So the wheel of accountability that you see there has 13 slices of the pie, and in the middle of that is the authority having jurisdiction, as they are the arbiter as to who does what how. So, and then you look at the slice of the pie, and it's things like the International Building Code and International Residential Code, state building codes, National Roofer Contracting Association, Underwriters Laboratory, International Code Council, the International Fire Code. So all these are the rules that we live with. And I'm going to try to address those that are most important over the course of the next, the remainder of our hour and a half time. So the first thing I will start with is the most important person, the authority having jurisdiction. This is the entity or organization or office that's responsible for enforcing the requirements of the code or standard or improving equipment. Essentially, they are your local building department, and they have tremendous latitude to interpret codes and standards the way that they feel they should be interpreted. That said, there are ways that we can have more productive discussions when there's maybe a misunderstanding or a disagreement. But that said, AHJs, the authorities having jurisdiction, interpret and make the rules based upon usually the state law and the state building and electrical code requirements. So states typically adopt verbatim the broad majority of the National Electric Code, the International Building Code, the International Residential Code, Fire Code. So all of these are typically adopted from the model codes, as they're referred to. But there are often variations not only in state adoption, but also in jurisdictional interpretation. One great example to explain how this can get confusing is looking at a map of the San Francisco Bay Area. Now, for those of you familiar, this is kind of from the city of San Francisco there on the peninsula south, and then Oakland right at the top of the map going south all the way towards San Jose in the lower right part of the map. Now, it's color-coded in these yellow and orange shades to represent soil liquefaction. Now, this is an interesting concept because if there's a seismic event, the soil that's color-coded in orange is the least stable. So if you have a structure built there, it would need additional reinforcement so it didn't have structural problems in the event of an earthquake. So what's interesting is if you look at the way the state of California gives jurisdictional authority to the local building departments, they state that you're empowered to amend the building, electrical, and fire code as long as it's predicated on unique conditions from 4 different categories: climatic, so that would be something like salt spray at an oceanfront area, which you have there in the San Francisco Bay Area clearly. Geological, which is this liquefaction is the proper term. So this liquefaction process where the soil loses its structural integrity would be a geological issue, interestingly related to the third category that you can make a change for, seismological. So obviously the San Francisco Bay Area, everybody knows, is a highly seismically active area. Not as much as Oklahoma these days, but still one that people are adapted to earthquakes. So you've got seismological considerations that certainly affect the areas that are shown on this map. And finally, topographical relates to terrain features. So if you have a narrow canyon, for example, that doesn't have as stable a soil, and that could be another variable that would cause a local building department to establish more structurally stringent building code requirements. So this is something to be sensitive to when you're trying to figure out, does the jurisdiction have the authority to make new rulings? Well, in California, they can do so if they can justify it on climatic reasons. So again, if you have a salt spray environment, they might say, well, you can't just use any metal you want. You're going to have to use, either stainless steel or aluminum. Those ones handle the salt spray better than galvanized steel in most cases. So that would be a requirement that could be imposed by a building department from a climatic standpoint. Geological, well, again, we discussed the soil consistency, and here it's variable. If it's not a bad day, the soil won't liquefy, but on an earthquake day, it can liquefy. If it's got a lot of moisture in it, it's going to be more susceptible to movement. So those are the factors. All right, so the codes and standards in solar, and hang on here while I just adjust this slide properly. Yes, here we go. The codes and standards that we're going to be discussing, again, break relatively into 4 groups: electrical, fire, building, and state codes. And then we have all of the standards. Now, there's some options when you have conflicts to resolve them. If you have a permit denied or an inspection failed, possibly due to a misunderstanding of the proper codes and standards language, you can always appeal to a higher authority. Now, a lot of folks are apprehensive, understandably, about appealing to a higher authority because they feel it might make getting their next permit challenging, and I respect that. But if you do want to appeal to a higher authority and you feel you're in the right, and you do it in a professional, polite manner, you can do so by taking your appeal to the chief building official, the city council, the county board of supervisors, the fire chief, whoever would be that next authority up. But again, it does have its potential risks. What I find is that when I've been contacted by customers with difficulties with permitting, more often than not, when I speak with the local building department, the issue gets resolved in a single phone call. As long as if there's a misunderstanding on the part of the building department, usually one phone call 90% of the time resolves the issues. So that's the thing, but you got to get those individuals that really know the issue well to speak with the authority at the building department to get that resolved. So that's the conflict resolution services that I've been engaged in my years with QuickMount PV. I'm also, as I chair the Codes and Standards Committee for the California Solar and Storage Association, I perform that service for members of CALSA when the circumstances dictate that that should be done. Part of the challenge and the difficulty that we're having is, rather than having electrical inspectors in jurisdictions, as was the case more commonly in years past, we are seeing a national trend from a cost savings perspective towards what's known as a combination inspector, which means that they might be inspecting electrical on one call and plumbing on the next call, and the footings for a foundation on the next call. So you couple that reality with the growing technical complexity of solar codes and standards, you can understand why conflict can be so prevalent and growing. Now, let's start a look at a racking system. I love this photo from the NABCEP conference, so 3 years ago, where, or 2 years ago maybe, where John Perlin, the industry's historian, held up a photo of the first rooftop PV system, and believe it or not, that was from 1884 in Manhattan. A fellow named Charles Fritz built some selenium cell modules using gold leaf film. They didn't produce a lot of electricity, but that was the state-of-the-art rooftop PV system. Looks kind of like me, like a big ping pong table. So that was the first rooftop PV system. And then you fast forward to the 1980s to take a look at a PV system, and this was state-of-the-art racking from the early 80s, where in the back you have a stand-up array custom fabricated with angle iron, and in the foreground you have what I like to call the only true rackless system I've ever seen, where those modules literally laid on the roof for decades. Of course, there was a really big wind block. This roof wasn't subject to much wind at all, and as a result, those modules just laid on the roof. That is a true rackless PV system, gravity held module. So that was state-of-the-art early 80s racking system. And you fast forward only about 30 some odd years, and you have now UL listed racking systems like the QuickRack rail-free system or our new QRail racking system. So that's the evolution that's occurred in the past 40 years, even though the evolution of the first 100 years of the PV existence wasn't particularly sophisticated. Now we've got much more evaluative methods to validate the key operating characteristics of a PV system. UL 2703 is focused on what I refer to as 3 major attributes, and those are the bonding and grounding of the racking system and the rails, the mechanical loading of the entire system, the module on the racking system, and finally, fire classification, or how fire resistant or how fast does the PV system burn if you have a fire that gets ignited, even if it's not related to the PV system operation. So those are the three attributes. Now, I always like to emphasize early in this conversation that roof attachments, those devices that you see pictured here that QuickMount is known for making over the years, those are not really part of the UL 2703 listing. And the reason is that part was left out intentionally because of the complexities that it introduces, because of the variations that occur in the industry. That said, obviously there still is methods of evaluating the compatibility of the roof attachment with the racking system. Typically speaking, this is done through load testing information and certification. So that said, UL 2703 is not applicable in the vast majority of cases to the roof attachment. Similarly, when you look at the system fire testing that's part of UL 2703, the UL listing does not apply to the roof attachment. The roof attachment, with rare exceptions, is not part of the fire test and therefore just not applicable to ask for a fire listing on a roof attachment. Now, to learn more about all of the variations in interpretation and codes and standards, I would strongly encourage that everybody participate in meetings such as the International Association of Electrical Inspector, which has chapters and section meetings where they bring together top electrical inspector officials from around the area of the country to learn and share information. So it's a wonderful opportunity for people in the solar industry to engage at a higher level with these key individuals in the codes and standards dissemination and creation arenas. You also have the International Code Council that develops the building and fire code that has chapters that meet on a regular basis. And finally, state building officials like the California Building Officials Association, or in the Northeast in Massachusetts, the New England Building Officials Education Association. These organizations have trainings annually where they bring building officials from around the area to learn about the updated codes and standards. In particular, solar is a major topic. So again, just as a quick summary reference, the key electric codes were in that transition for most states between the 2014 electric code and the 2017 electric code. Some states are on 2011 code. I know of areas that might go back even farther than that, but by and large, most PV systems that go in the United States are being installed under the purview of either the 2014 or the 2017 National Electric Code, which then get adopted by the states into their own code book. In the case of California, the 2016 California Electric Code is predicated on the 2014 National Electric Code. The 2019 California Electric Code will be predicated on the 2017 National Electric Code pictured in the upper right. So there's always a lag for states to adopt the National Electric Code. That said, understanding 2017 has tremendous value because it's not far off before most states will be utilizing it that are big with solar. The fire code is a little bit more involved in that there's two main code books that develop the basis for state fire codes. Case in point, International Fire Code is applicable in states such as California, New York, Arizona, while the NFPA 1 fire code is applicable in states like Massachusetts, Hawaii, Florida. Now, there's not, fortunately, as it relates to solar for the moment, tremendous variation from one to the next, but recognize that the state fire codes are based on either the International Fire Code or NFPA 1 fire code. Building codes and residential codes are what we refer to generically as building code. They address structural, including waterproofing. And most states tend to adapt that language verbatim with minor modifications. Solar standards include UL 1741 for inverters, 1703 for the PV modules, which includes both system fire classification and bonding and grounding, although fire classification and bonding grounding are slowly migrating to UL 2703, which is for the rack system, which includes the module. And finally, you have UL 3703 for tracking systems. Now, these These standards, UL 1741, 1703, 2703, are certified for by going to a nationally recognized test lab. There's 5 listed there that are active in listing to UL 2703 and 1703. Those 5 are UL, not to be confused with the standard creation division of UL. It's the test lab. That's a business. The test lab tests and makes money off testing. And they compete head to head on equal footing in the eyes of OSHA with Intertek, also known as ETL, TÜV or TUV, CSA, and QAI. All 5 of these labs are on equal footing to test to the UL standards for PV and list products. So when you see something that's got a QAI label that is tested to UL 2703, well, that's on par with something that's tested to UL 2703 through the UL lab. Product certification is different. It's intended to address equipment that's not specifically addressed by code language. Now there's 2 labs, ICCES and IAPMO EGS, that do certification of products to meet the intent of the code. And they do so, and they base it upon their own version of a standard that they call a criteria. So ICCES evaluates products to what's known as an acceptance criteria, and they test it. And if it passes, then they give you a certification for that product to meet the intent of the code. IAPMO does the same thing. They test and certify products through what they call evaluation criteria that meet the intent of the code. There's a few installation guides that are helpful to be aware of. The National Roofing Contractor Association is the de facto rule book when it comes to things like asphalt shingle flashing. So that green book in the left-hand side there is their steep slope roof manual, where you would find the asphalt shingle flashing guidelines. And the Tile Roofing Institute installation manual for moderate climate regions is the de facto installation instructions for flashing on tile roofs. Certification through NABCEP is done to validate installers' competency. So what I tell building officials, inspectors, obviously, if you see somebody who's NABCEP certified, there's no doubt in my mind that they have demonstrated a higher level of competence than somebody generally who's not NABCEP certified for understanding the codes and standards that would be applicable and really adhering to the proper principles of designing and installing PV systems in a manner that's going to be compliant with codes and standards. Now what we'll do is shift gears a little bit and talk about fire code. And in this case, we're going to be talking about the setbacks from the ridge and the pathways up the roof to provide for a firefighter's ability to fight a fire on the roof. And this all emanated originally from the International Fire Code, which established setbacks from hips, ridges, and valleys for vertical ventilation and established pathways for ridge access. And the basic premise, historically speaking, is that you have a 3-foot setback from the ridge, like you see here, with 2 pathways up each roof surface to give the firefighter an ability to haul his equipment up there and chop a hole in the roof where that ridge setback is. That was the basic premise. Now, the good news is that in recent years, we have been able to see the logic of reducing that setback and the number of pathways, and has gotten itself worked into the 2018 Fire, Building, and Residential Code. So these 3-foot setbacks and 2 pathways for most roofs will go down to 18-inch setbacks and 1 pathway up each roof surface. But you'll notice here these 2 pathways, and this is still applicable in most states, including California. These 2 pathways, each roof surface that has an array has to have 2 pathways. Well, you'll notice that pathway that's right on the valley between the 2 arrays serves both the right-hand side of the roof and the left-hand side. So that's how they comply. But with the new setbacks and pathways requirements, where they're going to require a single pathway, it's possible that some building departments might look at that valley and that pathway as sufficient to serve both the left and right side of the roof, meaning you could fit a couple more modules in both sides of the roof. So that's the implications that are coming into play with the new pathway. There are several sections of the fire code that you can check out, but I've gone ahead and summarized the key ones that are of interest to folks that would participate in today's webinar, starting with, again, the 3-foot setback from the ridge, which is being reduced to 18 inches in the latest version of the fire code. You do have those 2 pathways up each roof surface, which again, for most, but not all roofs, they do have some restrictions. We're working on diagrams and all the contingencies, but you'll be able to, the 2 pathways will shrink down to 1 pathway for most, but not all roofs. If you have a hip or a valley, the key thing that the code requires is that you have ability to get between the 2 arrays. Now, this is in the 2015 fire code, building and residential code. Again, with the new requirements, it's possible you might be able to go all the way up to the hip or valley on both arrays, and there won't be a need for a pathway between these 2 roofs as long as you have another accessible pathway that meets the new requirements. Another important consideration is it states the access pathway shall be located at a structurally strong location on the building. Now that's an interesting statement because many firefighters understandably do not view a valley as structurally strong. They view the gable end wall underneath the roof surface as structurally strong, but they're apprehensive about walking up between 2 arrays that are when there's a fire under the roof, because if you ever get inside an attic, you'll notice wherever there's a valley above you, the structural integrity isn't nearly as competent as when you have a wall under your feet as you would at the gable end of the roof in this picture. So if you have hips and valleys, the code books went into pains to state that you needed to have 3 feet between the array on either side of a hip or a valley. Some building departments interpreted that as you can't be any closer than 18 inches to the center of the hip or valley. Some of them said, you can take your modules all the way up to the center of the hip or valley as long as you have 3 feet before you get to the array on the other side. So that's a variable that occurs from jurisdiction to jurisdiction. The roof access points requirement that's listed here does state that you need to have ability to place ground ladders in areas that are strong points of the building construction that don't conflict with overhead obstacles such as tree limbs, wires, or signs. So that's an important thing to consider when you're looking at your site plan and the potential fire pathway. This particular exception is very important because in essence what it says is if the fire chief has said, you know what, we're not going to vertically ventilate that roof, we're not going to get on a roof like that, and there's a lot of reasons they might say that, then it gives you the ability to go to them to exercise this exception for the project, for the permit, so you could fill the roof with solar. So essentially it says PV panels modules shall be permitted, should be located up to the roof ridge where alternate ventilation method has been approved by fire chief, or he's determined that the vertical ventilation techniques will not be employed. And the reason that this has become an issue is that in recent years, many fire departments, particularly those that are more up to speed on the latest firefighting technology and techniques and approaches, have determined that while vertical ventilation was a functional way to clear smoke and gas when you were fighting fires or actually trying to perform life-saving activities, you needed to clear the smoke and gas, and that would give you maybe 5 or 10 more minutes to save somebody's life who might be stranded inside the house. The problem is that in newer construction, that technique works poorly because it accelerates the spread of the fire and makes things worse. So newer technology tends to employ horizontal ventilation, where you either open windows on either side of the structure to let natural air currents clear the smoke or gas. Sometimes you mount a blower on one set of doors or windows on one side of the building and seal off all other openings to clear the smoke or gas. And this reduces the amount of oxygen that gets in to feed the fire's growth, clears the smoke and flames effectively for life-saving effort. So when firefighters use horizontal ventilation, there's no need to go on the roof. And as a result, many fire chiefs will give exceptions to things like steep pitch metal panel roofs that are just difficult to walk on because they're too darn slippery, or tile roofs, which are heavy and riskier to walk on. So some fire departments have determined they will not vertically ventilate a tile roof if there's a fire in the structure. They'll horizontally ventilate. Lightweight roofs lose their strength quickly in a fire. So there's variables where you could appeal to the fire official to the fire chief to exercise IFC 605.11.3 access and pathways exception 2 and state, hey, you're never going to have a firefighter on there. Will you tell the local building department that I don't need any setbacks and pathways? I would strongly encourage that you ask those questions where it is going to be appropriate and helpful. Now, another interesting issue is vertical ventilation has determined to be problematic in making fires spread more quickly. So in older homes, again, you had smaller rooms, each with its own door, limited ability for air to exchange, and as a result, vertical ventilation was an effective technology. But newer homes not only are bigger and opener and airier, making vertical ventilation difficult to impractical, but the furnishings of modern rooms are made of things like synthetic fabrics, which are made of oil, which burn much faster than the old natural fabrics that were made from cottons and wools that made the draperies and upholstery and carpeting of homes from 30 or 40 years ago. So we've seen those timed flashovers in a legacy room shortened from about a half hour down to about under 4 minutes. And as a result, it's recognized that vertical ventilation is falling out of favor as fire departments adapt. So that said, in the low slope roof realm, there are several considerations such as a perimeter around the outside of your array, 6-foot perimeter. Then you have pathways and ventilation corridor requirements. So the perimeter requirement essentially says if you have a big building, you need a 6-foot wide perimeter on the outside of your arrays. But if your building's smaller, less than 250 feet either axis, it can be a 4-foot perimeter. There needs to be pathways around things like skylights, vent hatches, standpipes. Parapet walls have to have a 4-foot clear minimum. So there are pathways that are necessary just to navigate around the obstacles on the roof, and you need smoke ventilation corridors at least every 150 feet. So if you have a very large low slope roof array, you need to take a break every 150 feet of 8 feet to give a pathway to a firefighter to cut a hole through the roof like you see there if it's on a big box store and they want to get that ventilation as close to the origination of the fire as possible. So they want every 150 feet to have an 8-foot clear corridor to use for ventilation. Now, the 2018 code changes I referenced where the setbacks and pathways are being relaxed are still being digested. We thought this would be an easier process. It's turning out that because of the variables, coming up with diagrams is more complex. But to suffice to say, the basic premise is as follows. If your PV system is not of a huge, monstrous size, you're probably going to be able to go to an 18-inch setback from the ridge and have only a single pathway up each roof surface that has PV on it. That's the basic premise. If you have sprinklers, you get to have more variables. You get to load your roof up with more solar and so on and so forth. But those are the basic principles. So that said, we will now shift gears and talk about the UL standards for safety for PV system, focusing on UL 2703. And this photo here is our quick rack rail-free racking system. We now have our Q-Rail racking system, both of which are listed to UL 2703 with a broad range of popular PV modules. Now, the whole premise of UL listing is, do we want to have the kind of testing that you see pictured here, real world testing, or wouldn't it be safer to have laboratory testing? That's the basic premise of getting a UL listing, is that you're going to a lab to have this testing performed so that it's not done in a way that's going to cause somebody a problem if they were to make an error in the real world. Now, the standards I referenced earlier are listed in the left-hand column here. UL 1741 for inverters, 1703 for modules, 3703 for trackers, and 2703 gets most of our attention because it really is the standard that matters most to the typical PV installer, and partly because you're constructing the system on the roof that now has to meet this standard. So there's a lot more scrutiny that could be applied to make certain that that construction of that racking system, the modules, the attachment of the grounding, and the configuration of the grounding is done in compliance with the installation instructions, which would make it code compliant. That's the basic principle. And again, those nationally recognized test labs that OSHA has listed as eligible to list to the UL standards on the left are summarized there: UL Intertech, ETL, QAI, CSA, and TÜV or TUV. So those 5 labs are on equal footing to test and certify products meet the criteria of the UL standard shown on the left-hand column. And just as a quick summary, the 3 major attributes that these standards are looking at are bonding, grounding, mechanical loading, and fire classification. So we'll start with bonding and grounding, which is code required by the 2014 and 2017 National Electric Code, where the passages that you see here out of 690.4.43 state that you must that your PV equipment must be identified and listed for the application, and that you must use grounding and bonding part of a PV mounting system structure that's listed and identified for grounding. So that language essentially requires that you follow the UL standards for bonding and grounding. Now, UL 467 on its own is no longer valid for PV grounding. UL 2703 has environmental conditioning tests that make it relevant for PV grounding. So if you had a 467 listed lug, it's entirely possible that it may not be suitable for outdoor locations where PV obviously are positioned. So UL 2703 now is the appropriate standard, and as such is code required by the National Electric Code. UL 1703 is the standard for the module, and while there is grounding language in many module manufacturers' listings, the good news is there's reciprocity and recognition that if UL 2703 includes a particular module, it's recognized as compliant for bonding and grounding through the National Electric Code. So that's good. UL 2703 is essentially becoming the dominant standard as it relates to bonding and grounding. As it happens, I lead the task group on bonding and grounding for 2703, so it's definitely something I've spent a lot of my time with over the past few years. Now, there are several tests in the 2703 regimen. The most rigorous is the one that's outlined on screen here. It's called the limited short circuit test, where we surge 5,000 amps of power at 240 volts until the breaker trips, which equates to 1.2 megawatts of power for somewhere between 4 to 10 milliseconds till the breaker trips. And the purpose of this test is to verify that the grounding system, here it's our cross-section of our quick rack rail-free system, has the robustness to withstand a huge power surge in a short period of time. So this is a very robust test where that little pin that's piercing the aluminum anodization of the PV module frame to create a module-to-module bonding connection is really exercised with a massive amount of power. There is also another test called the bonding path resistance test, where you apply current, apply a voltage, and you have to make certain that there's no more than 0.1 ohm of maximum resistance in that connection. The bonding conductor test applies a current that equals 2 times the max rated for 2 minutes, and then a lower amount of current, 135% of the max rated current for 1 hour, to verify again that the bonding connection has the integrity, the physical integrity to withstand this overcurrent condition for a fairly lengthy period of time. And then finally, there's a bonding strap pull test that makes certain that when you've got some kind of a jumper like you see pictured there, that it's not going to come undone if there's somebody kicks it or if there's a small tug on it. So those are the major tests. Integrated grounding has really taken over the market, and in our quick rack rail free system for asphalt shingle roofs, you'll notice that those tiny little ground pins that those green arrows are pointing to, again, when you clamp the system in place, will pierce the insulating aluminum anodization that coats the PV module frame, that black coating, getting down to the bare silver colored aluminum, where you'll have a reliable bonding connection between the pin and the PV module frame and the next frame next to it. So that's the premise of integrated grounding, and it has become the norm in the industry. I will reiterate that UL 2703 bonding and grounding does not, except with a few exceptions, cover the roof attachments. Those are considered separately. They're considered to be metal accessories. In the vernacular of UL 2703 in section 9.1, we exempt metal accessories from bonding and grounding if they meet 4 criteria: if the system is non-separately derived, which is all grid tie systems, although we're removing that language and it's going to apply to non-separate or separately derived systems also. Your ground path is specified and marked. Metal accessories can't contact your conductive components in a single fault condition. Now that's important. What it means is if you strap your PV cables directly to a standoff, well, the bad news is you're going to have to ground that standoff, because if some of the insulation scraped off the cables, you'd potentially be energizing the standoff. But if you clip your cables up into the PV module frame with sufficient number of wire management clips, or you route them through a raceway and they can't make contact with your standoff or your flashing or your wind deflector or your bird screen, well, then you don't have to ground those parts because they could never be energized in an accidental fault. So that's the basic premise of section 9.1 of UL 2703, as it states that things like flashings and standoffs and bird screens and wind deflectors don't have to be grounded as long as your current carrying components can't make contact in a fault condition. And that's a good thing for solar installers. Now, there's a huge amount of helpful and required information in the installation manual. Here's our quick rack manual, where we will include things like the torque specifications, system fire classification information, which modules are permissible for use, the load ratings, upward, downward, and downslope, how much capacity each module would have for pounds per square foot, important in snow country, bonding and grounding instructions, inspection and maintenance instructions. You also have the ground path diagram, which will show the path current will flow in the event of an accidental fault, both in the left-hand diagram where it shows how the current would flow from the module frame through the clamp, through the bolt, down to the grounding lug and out the copper ground wire. And then when you're looking at the top view of the system, you can see which direction the current might flow in a fault current condition along the PV module frame if there is some kind of a fault condition existing. Now, all modules must be listed and approved in the installation instructions, and that's an important check that every building official should go through. As an example, the approved module list here for the quick rack system includes modules like LG, Solar, Trina, and other companies. Corrosion is another part of the evaluation to make certain that you don't have dissimilar materials that won't rot away over time. If you were to bolt bare copper to aluminum, what you'll see is what you see in that lower image. Over time, galvanic corrosion will set up a small amount of current flow, even if there's no current in the system. You just place a piece of aluminum on a piece of copper and leave it out in the rain. What happens is, naturally, because of the material properties, a small amount of current starts to flow, accelerated by moisture, particularly by salt, and it will eat away the aluminum over time and it will rot away to what you see there. We want to make sure that when the testing is done, we don't have dissimilar parts that are going to result in galvanic corrosion that could interrupt your bonding connection. Clearly, that bonding strap in the lower image is not doing its job anymore because the lug rotted right out of the aluminum frame. So another important consideration is the roof attachments. You need to verify as a building official, as a solar installer, that the span and cantilever are within the guidelines that are established in the installation instructions and by the engineering documentation shown in the engineering reports. So in the case of the quick mount PV Q rail product, the new rail-based product, if you run through the Q design tool, the online design tool, it will tell you your maximum permissible span between roof attachments and the maximum permissible cantilever or overhang for that last attachment to the end of your module. That's the important dimension. The edge of the module is where the cantilever is measured to. So the other important dimension or load capacities would be the upward, downward, and downslope, which will vary based upon wind load, snow load, and any other load that might be placed upon these. But wind and snow are the two that we look at most importantly. So those loads can be gathered through the online design tools or through structural engineering evaluation. As I stated before, the approved module list must be verified, and you have to make certain that the module is already an approved module to be eligible for the bonding and grounding approval as well as fire classification. Mechanical load test, can vary based on the individual manufacturers. Some will test with relatively minimal load ratings. Our Quick Rack product, for example, we've tested with 50 pounds per square foot down, 35 pounds per square foot upward, which allows it to work in a vast majority of the country with the exception of high snow load areas and possibly when you get down into the coastal areas around Florida with really high wind speeds that they have. The reason that these PSF capacities tend to be scrutinized as carefully as they are in snow country, or should be, is because you can get some significant buildups of snow that would weigh down on the modules, and you have to be careful that certain PV modules don't have the structural integrity and might not be able to support a heavy snow load like you see pictured there. So the other thing to consider is that the roofs are typically designed to handle this kind of snow load in snow country, so putting a PV system on there won't be a problem. Just keep in mind that not all PV systems have the capacity to support the volume of snow that a roof may be designed for. So this is the domain of a structural engineering report if there are any questions that may exist. So we are now finished with the basics of 2703 with one major exception, and that is talking about fire classification, which effectively is addressing how fast the PV system burns. And this used to be done in a much more casual fashion. Years back, they established the fire rating of a PV module. And then they realized, that doesn't really relate because PV systems tend to be mounted to things like roofs, and when they're mounted to a roof, the manner in which a PV system burns is really a function of an interesting phenomenon known as the thermal chimney effect, where air rushes between the roof and the underside of the module, and it can really accelerate the spread of fire. So there's now a new test, which you see pictured here. Actually, you're seeing one element of the new fire test called the burning brand test, where you have this cross lattice work of sticks that gets set on fire and put on top of a module. But the more extreme test is where they burn the roof and the module as an assembly and see how fast it burns. And that's essentially how the fire classification is established. So there's a good explanation on what now is the CALSA website, the California Solar and Storage Association, which has a common sense explanation of how this fire classification works, as well as a database of racking systems in which modules that are certified for. Most people have the fire classification under control, and it's fortunately not an overly complicated system. But again, it emanated from the fact that the early tests that were done just burned a module suspended in space, and it was decided about 10 years ago that, gosh, that doesn't really represent reality, so we better develop a new system, and about 5 years ago it debuted. So now we have a new fire classification system based upon burning a module mounted to a roof. And this all emanated from the building code in 2012 originally and carried over to 2015, that states that your PV system has to have the same fire classification, essentially the same fire resistance, of the roof that's required for that home. California refined that further and stated that you have to use the UL 1703 fire classification system, which is the same now as the UL 2703 fire classification system, where you burn up an assembly like you see right here, and then you rate the roof based upon how quickly the flame travels uphill. A Class A roof is the most fire resistant, the flame will travel the least. Class B roofs, it travels a little further, Class C a bit further, and that's common in residential roofs. Class C fire rating is a normal, common rating, except when you get into the more wild or fire-prone areas where Class A roofs are mandated, and that's pretty common now too. Unclassified just means it hasn't been tested or couldn't pass Class C. But a Class A roof requirement is what everybody aspires to because it's the most fire resistant. And this is important because many communities like Oakland, California or Santa Barbara have imposed Class A fire requirements for all roofs, regardless whether you're in the inner city where wildfire isn't a problem or in those foothill areas where it's a real problem. So that said, wildfire danger has driven the industry towards making certain that all residential racking systems have a Class A fire rating regardless of the module. Now, you're going to hear this term potentially of typing of modules, and basic principle is that you don't want to have to make every racking company test every manufacturer's individual module in a fire test. That's impractical. And what they found is that most modules burn pretty much similar like the next module. So they established something known as types. There's 15 of them. But by and large, they're based on construction characteristics like your glass thickness, frame type, and capsuline thickness. But when all's said and done, the good news is it breaks down real simple. Because while you have 15 types, almost everybody in the solar industry residential uses type 1 or 2. That's it. That's 90 some odd percent of all the modules out there. Probably 99% of the modules used residentially are either a type 1 module or type 2 module. And the only difference between a type 1 and type 2 module is the fact that one's got a thick plastic backsheet, the other's got a thin plastic backsheet. That's it. So you don't have to worry too much about the types. The racking manufacturers have got a handle on that. But the important thing to realize is that when these tests are done, they're typically done at a 5-inch default air gap. And the reason that this air gap has been established is it was noted to be the point at which the flames spread the most quickly. So since this is the worst case scenario, it means that if you can pass the Class A fire rating at a 5-inch gap, your PV module could be spaced 4 inches or 3 inches and the fire will go slower. Conversely, it could be spaced at 6 inches or 7 inches, and again, it will go slower. 5 inches is the worst case. When it's higher, it goes slower. When it's lower, it goes slower. So if you pass Class A fire rating at 5 inches, you're golden. The installer has the latitude to install at any height off the roof they so desire. Now, the roof attachments, as stated earlier, are not bound by UL 2703 fire rating. So if a building official says, what's the fire rating on that attachment? The response, and I can provide it if you ever need my assistance in doing so, is that UL 2703 does not apply to the roof attachment. That is just the basic reality of it, for better or worse. The quick rack system uses a leading edge deflector. The good news is we tested the fire rating both with and without the deflector and got a Class A fire rating either way. So you don't have to worry about whether that might influence the fire test. On low slope mounts, they do test the classification a little differently, where they shoot fire at it from the south edge, the east edge, and the north edge, because they know that fire can come from any direction on a low slope roof, to see what the flammability is. And if you do use any kind of deflectors to improve your fire rating, it would be mandatorily required to use those to meet that fire classification. Now, the important thing that I recommend solar installers and building officials look at is what the fire rating is required for that building. Typically speaking, homes in a wildland urban interface, an area subject to wildfire, have to have a Class A fire rated roof. Most commercial properties are required to have a Class B fire rated roof, and the majority of residential structures only need a Class C roof. I'll reiterate that the racking manufacturers have said, you know what, even if only 10 to 30% of the homes need Class A, we're just going to assume that everybody's going to get a Class A fire rated system. So even if you're in the inner city with no danger of wildfire and your roof requirement only has a Class C requirement by the local jurisdiction, you're still likely going to be buying a PV racking system that has a Class A fire rating. That's not a bad thing. The documentation one would need would be either called a certificate of compliance if it's from UL, or a letter of conformance if it's from Intertek, or there's other terminology to the official document that validates the racking system does comply with UL 2703 fire classification. Similarly, the module must have gone through the typing for UL 2703 fire classification. You can read more about it at the CalSA website now. It used to be CalSIA. And we have a nice article that explains how this works with a spreadsheet or database of racking manufacturers and which modules they've tested. And there's a couple articles linked here that you can learn more in Solar Pro magazine, as well as Solar Power World, a podcast, to better understand the fire classification. The good news is it all is fairly understandable. So it's nothing terribly complex. We don't find much confusion. Generally, when building officials in new jurisdictions first start looking at it, the biggest confusion is, oh, is the flashed roof attachment have a fire rating? And the answer is no. All right, so we talked about the installation manual, how it has all of this important information, including system fire classification. We have that both for our quick rack and our new Q-Rail rail-based racking system. We also mark our listings on the flashing product or in the accompanying documentation for the component parts of the Q-Rail system. So with that, we are finished with the fire setbacks, with the UL 2703 fire classification and all of the bonding and grounding. And now we're going to shift gears and talk about, for the remaining half hour of our time, about the waterproofing code requirements that are established by the Building and Residential Code. So this picture we like to show because it shows several things that are problematic. No fall protection. Penetrations are not staggered on the trusses, which is becoming standard procedure for many building departments throughout the country. But more importantly, we do not see any visible flashing here, which does not meet the building code requirements for proper flashing on asphalt shingle roofs. It would void the warranty to not follow the code requirements. And in years past, we would see frequently sealant as the only waterproofing barrier where there was no metal flashing. It was an L-foot or a track style mount bolted directly through the shingles, through the deck, into the rafter, and these penetrations were entirely dependent on sealant. But over the course of a few years, water is a tenacious invader and can penetrate the smallest cracks and crevices. And in this example, despite the generous amount of sealant around the perimeter of the roof attachment, the water was able to get in. You'll note the corrosion in that right-hand image after about 5 years of performance. Plain and simple, sealant is not realistic for more than a few years of reliable waterproofing. Here we have an installation in New Jersey, no metal flashing again, and the leak was so bad that even though the installer tried to patch it with a bit of sealant just to the left of that red arrow, it's still saturated through the underlayment into the decking and the rafters below, caused wood rot, and that dark stain that you see the red arrow pointing to is actually the wood rot underneath the shingles. This is a common strategy for folks that feel sealant might be their only option, is use extra sealant, which buys limited extra protection. More sealant isn't going to give you more long-term reliability. It will still crack, water will still invade it over time, over more than 5 years. Sealant is not a very reliable waterproofing measure. Now here's an interesting photo showing some pipes and wires going through the roof without flashing. Now the current carrying conductor that you see there, and I don't know if it's for something that's low power or high power, but certainly the National Electric Code would not permit current carrying conductors to go through the roof without protection of conduit. So that is, or a transition box more appropriately. Obviously, we've got a serious leak risk here too, because as you can see when we enlarge the drawing, the small gaps can become funnel points for water and create serious problems. So one of the things we want to be careful of is improper installation of flashings, because it can set up a long-term structural concern, to say the least. In the left-hand image, we see a flashing that's been nailed through the downhill side, which is not compatible with the National Roofing Contractors Association's prohibition against exposed metal fasteners. Essentially, when you've got a water-shedding roof, like a shingle, overlapping devices that require gravity and elevation, meaning you have to have a certain amount of pitch angle for water to be able to not back up under the shingles and cause a leak. So you never want to have exposed metal fasteners. You want those fasteners to be uphill, covered by the layer of shingles uphill. And by putting a nail through the flashing, now you're setting up a corrosion concern. It's pretty evident that we have some serious corrosion going on that's going to mean that we're going to have a leak coming pretty soon, because those nails are just corroding away. Additionally, we have a water capture area formed by taking some hose clamps and compressing the rubber seal down into the metal flashing, creating a water capture area that will intensify the UV exposure for the rubber that's underneath the water. It acts like a magnifying glass, also harbors biological growth, which can deteriorate the rubber. So bad all the way around. The flashing on the right was literally laid on top of the shingles and glued down. That's misapplication. Here's an example where the flashing is not installed at the right layer of shingles. This is sitting on top of the shingle. It should be underneath, and that's evidenced by the fact that the top of the flashing is visible there. Again, this installer, in a feeble effort to prevent water from leaking in, put a bit of sealant where the red arrow is pointing, but this is not installed correctly, so the upper portion of that flashing should be under the shingles that it's sitting on top of. So this needs to be removed and reinstalled under the correct layer of shingles. Deck level seals are an interesting issue that we see a lot of being used today. Certainly better than a sealant only solution. Unfortunately, water will be working on that seal since it's right at the water line, particularly if you're in a freeze thaw zone. So be sensitive to the vulnerabilities of deck level seals over time. And there's a good video on the Quick Mount PV website that shows the progression of water damage over time. The basic premise of Quick Mount PV's elevated water seal is raising the vulnerable water intrusion area above the water line to minimize the potential for moisture to cause any damage to the seal area over time. This is a particularly interesting consideration when compared to deck level seals, particularly in a freeze thaw zone where that water as it freezes can exert tremendous pressure on the rubber seal. By elevating that sealing surface above the water line, you greatly reduce, if not eliminate entirely, any damage that can occur over time to the seal from the water flowing past it. You can learn much more about this process by checking out the Quick Mount PV website, where we have some really helpful resources to better understand how water can work its way past a seal and the damage it'll do once it does start to work its way past the envelope, the roofing envelope. Sealant only solutions like you see pictured here are never permissible from the standpoint of the low slope roofing manufacturer. When you've got what some people call a flat roof, technically speaking, it would be referred to more appropriately as a low slope roof, because no roof is really flat, and you never have roofs that are oriented to the horizon. But they do have less pitch angle than a typical shingle roof, obviously. And in those types of roofs, to have a seal like pictured on screen is highly unusual. And the reason for the aversion by the low slope membrane roofing manufacturers to the kind of deck level seals pictured here is due to the fact that when you've got ponding water, if your drain gets plugged, the hydrostatic pressure that can be exerted upon these deck level seals is significant, increasing dramatically the potential for risk problems over time. So sealing with just a simple rubber seal or sealant in these applications is really problematic over time. Here's an interesting example of a ballasted attachment. I don't believe this is for photovoltaics, but an installer sent this to me. It was from Southern California. It hadn't rained for 6 months, but notice that the ballast pad on this membrane roof underneath it, you could see it probably was depressing into the insulation a little bit, creating a nice water capture area, which grew some mold, which, while it hadn't rained for 6 months when this particular image was taken, just was waiting for that next rainstorm to reactivate the growth of that blackish green mold that's growing on the membrane, slowly consuming it. So this is one of the cautions that I would offer to anybody in the roofing realm and the PV realm, is that you don't want these ballast pads to become the water capture point. So you have this kind of biological growth that can be problematic from the standpoint of life. And here's an image that I'd like to show, if for no other reason, it really reinforces why what's called 0-degree pitch systems aren't practical. If your PV modules are oriented or flat to the horizon, they become a shallow pond whenever it rains. And if it's in the desert Southwest where I live, you often get that dirt and dust that then bakes onto the module in a pattern like you see here, causing massive reductions in power output. You got to clean the modules. So I would certainly encourage that all systems installed on roofs have ideally a 10-degree tilt, minimum 5, just to sheet the water off. 10 degrees certainly keeps the modules cleaner, and this will help your long-term system performance. Obviously, anytime water's feeding these kinds of biological growth, it's going to eventually consume that which is growing on. So this particular slime is slowly consuming the rubber boot flashing that it's growing on, and this is a common problem that has to be faced in places like the Pacific Northwest. This is a major safety hazard where we have PV cables going across a asphalt shingle roof. Not only could it scrape insulation off the cables, creating a potential for an arcing, sparking fault condition that could either be a shock hazard or a fire hazard, but it also scrapes the protective granules off the asphalt shingles, exposing the underlying asphalt, more rapidly wearing out the shingles there. So this is a problem both electrically as well as roofing wise. Now this is a very common situation where we see a tile roof attachment without any flashing at the underlayment level. This is a track style mount. Here we've got a standard hook style mount. And either way you look at it, by not having a flashing at the underlayment level, you're not in compliance with the Tile Roofing Institute guidelines. And these photos from Miami were sent to me, my friend down in Miami-Dade Building Department. And look at this module hanging over the ridge in a hurricane zone, and that rail is clamped at about the halfway point of the module. So this would be highly inadvisable structurally. The wires were strewn across the roof. There's no visible flashing. This was a train wreck of a PV system, demonstrating the common problems that we see out there in industry. Here's an example of a system with no flashing. The PV cables look to be somewhat more controlled, but not great, but they haven't fixed the broken tiles, instead electing to patch them with some kind of a white substance, which would not be practical. Those broken tiles need to be replaced. When you miss the rafters, that also is in violation of the code. Now you've also got a roof attachment that's no longer structurally robust to the roof. So every time you get that expansion contraction of the PV system moving with the heating and cooling cycles, you're going to end up with the potential for leak problems like you see here, where that lag screw has totally missed the rafter in the left image, partially into the rafter on the right, but the leaks you can see now have developed because that system can move around more during the expansion contraction. And look at the wood rot that's going on the right. When that wood rot gets worse, it can end up requiring structural reinforcement of rafters and replacement of the sheathing. The sheathing on the right was so rotted through that my buddy Marshall was able to stick his pen through the wood decking and raise the shingles on top of the roof. So this is a serious problem that needs to be remedied. In this tile leak problem, you'll see that the sheathing is rotted away in a pretty good section there, and somebody has probably stuck their foot through it. So that's another common occurrence that happens even in dry tile climate. When that leak progresses to the interior, of course, drywall damage costs about $500 and up to fix. Mold remediation starts in thousands and can go into the tens of thousands. So don't underestimate the damage that can occur structurally and otherwise with leak problems. Now, this is dictated from a code standpoint by the building and residential code that recognize that sealant alone is not sufficient for waterproofing, because over time it cracks like the image on screen. Within 10 years, water will invade those cracks and problems result. So the premise of a flashing is to divert the water away from the penetration with a reliable seal like our elevated water seal, and then having enough side lap on the flashing, enough width to keep the water away from getting to the penetration at all. Which begs the question a lot of people ask, well, do I really have to waterproof a lag screw? And the answer essentially is yes. Whenever you've got a penetration, you have to flash it, and penetration is any construction passing through a roof. This quote from John Shale, Executive Director at the RISE certification program, also the former NRCA, National Roofing Contractor Association, Associate Executive Director of Education, states that if you got a screw going through the roof, it's a penetration. It needs to be flashed by the I code. Now, the I codes are the International Building and Residential Code, written by the International Code Council, that require use of flashing for all penetrations, and more importantly, installing that flashing per the roof manufacturer's installation instructions. And if you go through and read the sections in the Building and Residential Code, you see where it says flashing shall be installed wherever you have penetrations. The Residential Code says virtually the same thing in slightly different language, that flashing shall be installed where you've got other penetrations. More importantly, it states that flashing must be installed with approved manufacturer installation instructions, and in the case of shingle roofs, you must comply with the shingle manufacturer's instructions. The residential code says, again, the same basic thing, that you have to comply with the shingle manufacturer's printed instructions, and you have to install flashing in accordance with manufacturer's instructions. Now, the building and residential code state you need flashing per the manufacturer's instructions, and most of the large shingle manufacturers require that you use metal flashing for penetrations, that you provide 4 inches of side lap coverage, and that you flash up into the third course as is described by the National Roofing Contractor Association guidelines, which can be found in their steep slope roofing manual, where they call out several materials that can be used, including galvanized steel, Galvalume, stainless steel, copper-coated stainless, aluminum, lead-coated copper, copper, or lead. So those are the metals that they allow for flashing. They don't allow any other materials. It must be a metal flashing, and they require that the upper edge of the flashing be lapped by the third course of shingles. First, I'll address the metals, then we'll talk about the installation. So the materials, the galvanized steel that is permissible may not be suitable for higher moisture areas, particularly those in a coastal environment. This is a photo of a friend of mine who lives down in southwestern Florida, of his galvanized steel flashings after 4 years of service, where all of them had some significant visual surface rusting, as you see in the images on the left, but the worst of the flashings had holes that had rusted right through. So while galvanized steel is a permissible flashing material by the NRCA, it may not be suitable for wet climates, particularly those that are in a more coastal environment, a warm coastal environment. Now, the NRCA manual includes a lot of guidelines and recommendations. Where possible, they want your flashing to be integrated into the underlayment, and they want you to have a minimum 4-inch side lap, which is why the E-mount for quick mount PV offers 4.3 inches of side lap. The L-mount, the newest product, the least expensive, also offers 4.3 inches of side lap, which is in excess of what is required by the NRCA. The classic comp mount, which is our most robust product, gives 5.8 inches of side lap to give better protection against wind-driven rain and capillary action. The flashing thicknesses also are thicker than what the NRCA requires. The NRCA only requires aluminum to be 32 thousandths thick. The E-mount and the L-mount both use a 40 thou thick flashing. The classic comp mount is the most robust at 50 thousandths inch thick. Positioning of the flashings per the NRCA guidelines is per the diagrams you see here. The position in the center is the ideal configuration, where you have the flashing just a little bit above the butt edge of the shingle that it's sitting on top of. And that positions the upper edge of the flashing, denoted by the dash orange line, well into the third course. Now, you'll need to remove those nails, and that's something you do with a roofing bar. Straightforward procedure. You can always move the flashing a bit further uphill, as is shown in the right-hand position there, where you'll have to trim away some of the shingles so the mounting block has sufficient clearance. I always recommend a 1/2 inch minimum clearance. Now, you don't have to cut it out as a nice semicircle as is shown here. You can just use some snips and cut a straight angle to conform to the 45-degree position of that mounting block. But you do need to remove the nails, and either position is acceptable. The position on the left is incorrect. The overhanging edge is bad, because what it will do is it will allow moisture to grow, biological growth, and it will consume the shingles underneath that overhanging edge. Additionally, the bigger problem is that you haven't gotten your upper edge of your flashing into the third course. You need to pull those nails and push it further uphill about 1 inch, and then you'll be okay. So the position on the left is incorrect. If you're positioned, unfortunately, over a keyway area where 2 sections of shingles meet, then you would have the potential for water to run right down that keyway and reach your penetration. So these are the orientations of the flashing. The one on the left is wrong. The one in the center and the one on the right are perfectly acceptable. Generally speaking, you'll position the flashing like you see in the center because it's the easiest. It doesn't require shingle cutting. Now, to remove the nails, it's straightforward. You'll use a roofing bar like you see pictured there. It's a product that Quick Mount PV offers. It's sold at a lot of distributors, and it allows you to break the seal between the shingles and to remove the nails. It does beg the question, is it code compliant to remove nails? And for those that want to download this presentation and read this section, you can do so. But in essence, it states that the building code requires that every section of shingles be held in by 4 nails. Well, the good news is that a standard 3-tab section of shingle is held in by 8 nails total, so you can remove several and still be compliant, but in most cases, you would only be removing a single nail. GAF, the largest manufacturer of shingles in the US, actually acknowledges this procedure in their installations instructions, which clearly state that any nails that you remove would just be filled with sealant before the flashing gets put in place, and they're showing our classic comp mount in their instructions. Occasionally, we've seen people make mistakes where they install a flashing in architectural shingles in the incorrect position. This, unfortunately, was installed 1 layer of shingles too high. They need to remove this flashing and install it underneath the shingle it's currently on top of in order for enough of the side edges of the flashing to be covered. So this was application error, unfortunately. Now, we've gotten approval from most major shingle manufacturers on the asphalt shingle flashings, including GAF, CertainTeed, Pabco, Malarkey, Owens Corning, IKO. So we've got those letters that can help validate that our flashed mount will not void their roofing warranty when installed in compliance with the installation instructions. In the realm of low slope roofs, the rules are different. In the case of a Sika Sarnafil membrane roof, they require that any penetrations be flashed with a flashing that has an 8-inch minimum height above the roof deck. Sometimes they'll accept 4 or 6 inches depending on the circumstances, but the roof manufacturer makes that determination. And in the case of tile roofs, the tile roof manufacturers that are the largest companies have band together and formulated installation guidelines that are developed by the Tile Roofing Institute, which publishes the installation manual for moderate climate regions, which is a really good document that shows in detail the flashing requirements for all tile roofs. Now, these guidelines or installation manual is certified to meet the code by IAPMO, and in the certifications, they call out that well, first and foremost, the certification of the instructions is shown on this slide, but more importantly, Eagle Tile, who's the second largest tile manufacturer, specifically states that all flashing or the installation of the tile must be done in accordance with the Tile Roofing Institute installation manual. Similarly, the largest manufacturer of tile, Boral, has published a letter stating that the Tile Roofing Institute guidelines are the official installation instructions. And so we have both Eagle and Boral, which have certified their tile to the TRI installation procedure. And they've written letters stating that the Tile Roofing Institute instructions are the official method of installing their tile and flashing. And in those instructions on page MCO2, they detail what the flashing requirements are. Now, if you punch a hole through the tile, you must flash that tile with a flashing that has sufficient side lap. When you penetrate through the underlayment, you have to flash at the underlayment level. So you have to have flash at the tile level if you poke a hole through the tile, which you do with a standoff. And you need to flash at the underlayment, which you do whenever you put a bolt into through the underlayment into the deck, into the rafter. So the requirements by the Tile Roofing Institute is that you must have underlayment flashing. And the reason, whoops, sorry about that. My presentation just jumped out of sequence. Let me get it started right back. There we go. So the reason is because water blows between tile. Now, this is a picture from my tile roof in Chandler, Arizona at year 16, showing the underlayment with water tracking between the wood battens that the tiles mount to, and all across the roof, north, east, south, and west side of the roof. We had water tracking down the roof because on rainstorms, water blows up between the tiles and then drains harmlessly down the underlayment to the eave of the roof where it drips over the drip edge. So this is the water traffic pattern that had developed over the course of 16 years on my tile roof. And this is the reason why the Tile Roofing Institute requires that you install a flashing integrated into the underlayment at the deck level whenever you put a lag screw into the deck. Now, the tile level flashing is required whenever you poke a hole through the tile, which you do whenever you install a conventional standoff. But a tile hook doesn't penetrate through the top of the tile, so no tile level flashing is required. However, a tile hook, like you see pictured here, still has to have a flashing at the underlayment level. And this is a great photo of Carlos Maldonado, Quick Mount PV's star tech support rep, installing a metal flashing on a tile hook on my tile roof right to my 90-pound mineral coated granulated rolled roofing underlayment. So that's on my roof here, and it's being installed with a 3-course sealing method, which is permissible for most building departments. I will reiterate that not using a flashing at the underlayment level, like you see with this tile hook and track style mount, is a violation of the Tile Roofing Institute manual and therefore would not be compatible. Now, the installation procedure is pretty straightforward, where you install, in this case, a standoff to the rafter. You'll then install underlayment bibbing under the batten uphill so that the underlayment gets tucked into the course of underlayment uphill. You'll install the tiles, cutting the hole where necessary, and install the tile level flashing. So here we've got a flashing at the underlayment level to stop any leaks occurring when water blows between tile, and a flashing at the tile level to minimize the amount of water that gets to the underlayment at the hole that you had to create. Here's a closer view of this bibbing process where we have the 9-inch by 9-inch metal flashing installed at the underlayment level with underlayment bibbing surrounding that to give it more side lap protection, tucked into the underlayment uphill and underneath the batten. The alternative approach is what's known as 3-coursing, where you would attach the metal flashing to the deck level with nails only in the upper 2 corners. You would then cover with a generous coating of mastic around the perimeter of the flashing and the deck, into which you would press into the wet mastic a fiber reinforcing mesh and finish with another layer of mastic, which forms a really thick, robust, leathery seal that's really good for the long term. So this is an acceptable procedure for the vast majority of building departments. Flexible flashing is unproven. It's unacceptable by the Tile Roofing Institute for asphalt shingle, I should say for asphalt impregnated felt papers. It might be the appropriate flashing material, but only if you have a synthetic underlayment roof. Now, I will caution you that there has been a bit of controversy in the synthetic underlayment realm where a lot of synthetic underlayments were experiencing leak problems. So I'll caution any solar installers when they see a synthetic underlayment, before you decide the best method to seal the flashing plate to the underlayment, verify that that particular underlayment is not one of the varieties that was subject to the leak problems. You can find out more by going to the Western State Roofing Contractor Association, who has a database of which materials were problematic. But if you've got one of the good underlayments, then using a piece of self-adhering underlayment as the 3-coursing material would be the proper approach. However, flexible flashings like you see here have not proven to be reliable on organic felt papers. Asphalt impregnated felt paper doesn't have the reliability with this flashing method at this stage. Sealant only solutions are not permissible. So when you're trying to figure out which method the TRI accepts, well, this is a quick summary. Bibbing with the same underlayment that was originally used is a great approach. 3-coursing with mastic and reinforcing mesh is acceptable and an excellent long-term waterproofing. Flexible flashing, if it's used on synthetic underlayments, may be the proper underlayment. The TRI hasn't come out and endorsed it because they're apprehensive about the leak problems, I think, that exist with some of the synthetic underlayments. But its long-term waterproofing protection is still uncertain because of that uncertainty over the synthetic underlayment life. I think some of them are perfectly fine, but in that case, you must use the waterproofing measures that the synthetic underlayment calls out. Typically, it's using some of the self-adhering underlayment to adhere to the existing underlayment in synthetic world. Sealant-only solutions are not approved and are poor long-term waterproofing. Now there is a nice conduit mount for tile that's available, and conduit penetration flashings for tile that will allow you to reliably, waterproofly take your PV cables into the attic with a piece of conduit. I will state that roof slope matters from the code standpoint, where the roof in the background is a steep slope roof, the roof in the foreground is a low slope roof. Shingles can only be used on 212 roofs or greater. 412 pitch is best. The roof manufacturers prefer to have more slope to make the shingles work better. Whenever you're less than 412 pitch, you're going to have to use special waterproofing provisions. Here we've got a 112 pitch roof that never should have had shingles. It leaked within the first year. So in our asphalt shingle webinar, we train contractors how to spot shingles that are worn out and need to be replaced. Ones that are cracked or curled are problematic for sure. Blistering may be an avoidable or ignorable problem. Mold problems can be remedied in many cases, but curling is an advanced state of wear of the shingles. In the same token, tile underlayments, when they're curled, like you see the upper picture, that was my tile underlayment at year 16. When we ended up totally replacing all the underlayment, and that was just worn out. It wasn't leaking yet, but another section of my roof was, and you'll see that the underlayment in the lower image there that was at 16 years facing southwest was baked dry, cracking, brittle. So the expected life of a 30-pound felt underlayment in the Phoenix metropolitan area is between 15 to 20 years, and I'm personal evidence of that exact scenario. As far as centering your lag screws, the American Wood Council's national design specifications dictate where the lag screw would be in a 2x4 or 2x6. Suffice to say that when you do the math, it comes down to the center third of the rafter or truss is fair game for locating a lag screw. Now, we do have a good webinar, or I should say a video on our website that shows the different methods for finding the center of a rafter. The most recent device that I really like is made by a fella in San Diego. That's a feeler device that allows you to stick it through a hole drilled and rotate it and find how far you are from the rafter, made by a fella named Chip Jarvis down in San Diego. I'll incorporate that into future webinars once I have more detail on it, but he's just in the early manufacturing stages of this patented device, which I really like. Check out that video on our website and you can learn more about the different methods for finding rafters. We did some testing a while back to determine if pilot holes really helped you get avoid splitting rafters, and the end result was absolutely. Drilling pilot holes is always desirable to avoid splitting rafters or blowing them out. And here's an example where the rafter is not fully blown out, but the fact that the fastener is so close to the edge of the rafter caused it to splinter. So that's a partial blowout, one might say. And if you have the bad luck of even a drill tip fastener like a GRK screw, if it follows the wood grain of a knot, it can stick out the side for a shiner. So that's something we want to avoid wherever possible. One final item that I will communicate before we wrap up is there's an interesting issue that comes about with hip roofs. Now, traditional wood framing roofs are built with rafters on site where they're cut to exact sizes, and it's certainly more versatile approach, but most structures today are built with plated wood trusses or engineered trusses. While you do have a higher material cost, you don't have to have skilled labor. You can get greater spans and very little job site waste. And we've got all of these diversity of different truss types, but we're going to focus in on what's known as the hip truss, because the hip truss has got a funky principle as it pertains to solar installation. So in this roof, we have a regular old gable fink truss that you see in the top part of the image, and then a hip truss where it's kind of just a squared off top, and then you have standard monopitch trusses that are oriented at right angles to the hip trusses. The problem is when you're installing on a roof like this, well, a monopitch truss is kind of running in the direction everybody assumes rafters run, and then when you get up to the higher part of this hip roof, you run into that hip truss. And the dilemma is, if you got your PV modules laid out, the top part of this array now has to bolt into a hip truss. Right there, where those two circles are, we got to bolt to that hip truss. The problem is a hip truss isn't square to the roof deck. Well, you can't just bolt right into the hip truss at an angle. That's not a structurally sound approach. So what you need to do, this is not an appropriate system, is you have to install wood blocking between the two truss top cords and then install into the wood block. That is the appropriate method to install a roof attachment when you've got a hip truss roof like pictured. So that's it, folks. That's the entirety of our content. I will just finish with these two checklists that we've made for permitting, where we'll ask you to check for the fire access pathway setbacks, verify the ridge setbacks, the location and the number of pathways. We'll encourage that before you go to permitting that you verify your system fire classification per UL 1703 and or 2703. They're both the same, but it might be listed under 1703, or it might be listed under 2703. Then you'll look at the bonding and grounding of the system through UL 2703, the mechanical loading, looking at the up force, the down force, and the down slope force, and looking at the waterproofing to make sure that it meets the applicable codes and guidelines for the jurisdiction. The tile penetrations need to meet the TRI guidelines for flashing, having a deck level flashing, and then your asphalt shingle mounts meet the ARMA and NRCA guidelines. And I've given these checklists for an inspector that talk about the setbacks, fire rating, looking at your cable securement, your attachment screws, and your waterproofing. So that said, we are wrapped up. Before we go, I just want to remind everybody that Quick Mount PV offers a broad range of roof attachments for virtually every roof type, from asphalt shingles to tile, shake, slate, metal shingle, low slope roofs of all flavors. And our new Q-Rail racking system is now available. Plenty of information on the website. Check it out. It's got 3 rail sizes: heavy, standard, and light. Light works for most of California, Arizona, Nevada, so on and so forth. Standard rails would work for most of the rest of the country. Heavy rail would be used in ground mounts or in roofs that have really substantial structural beams that can accommodate longer spans, in both a black and a mill finish, with cool tool-free internal splices that make the installation fast, easy, reliably bonded. There is an optional external splice if your mid clamp might fall right where the splice is at, and the clamps themselves click in really easily, securely, won't pull out if you over torque and damage the rail. The Q design tool makes designing the Q rail system easy, allowing for more sophisticated layouts such as a staggered approach like you see here, combination portrait and landscape modules on the same roof surface. It will generate your bill of materials and an engineering report. Quick Rack rail-free system. There's more information at the Quick Mount PV website on this rail-free racking system for asphalt shingle roofs. The L-mount has been available for several months and is becoming a very popular product for many installers around the country that want to trim their costs without sacrificing quality waterproofing over the long term. I'll mention again that the L-mount sits a little closer to the roof since you don't have that rectangular block spacing it up a little bit. So some people like to keep some E-mounts and L-mounts in their truck, which allows them to accommodate larger variations in roof height if you've got a roof that's not particularly flat. The E-mount now comes with rounded corners and the alignment guide notches pictured here. The Q-box allows you to bring your PV cables into the roof in a waterproof elevated water seal manner. The tile replacement mount replaces the concrete tile with a form-fitting metal flashing that yields an unbroken concrete tile that can be used for service elsewhere on the roof during installation. And we now offer that same convenience in tile replacement flashing, a form-fitting metal flashing that replaces the tile over any kind of a tile hook on the market. You can get all these products by clicking the green free sample button on the website. Check out our podcast. You can quickly find it by doing a web search for Solar Roof Talk, co-hosted by myself and Sue Stark, where we talk about issues that are of interest to rooftop solar installers. And the mobile training centers crisscrossing the country. Contact the sales department to see if we can schedule a stop at your place of business. If you have any questions, we've got a live tech support number shown there. Emails for the Director of Training, Sales, and Tech Support are on screen also. And at our website, you can find our frequently asked questions as well as complete product information, engineering documentation, training downloads, trade shows and event listing, a list of distributors, and don't forget to get your free sample by clicking that green button. The events that QuickMount will be exhibiting at this coming year include the ones on screen. We're already halfway through the year almost, as far as the trade show schedule is concerned. And the next event will be the Midwest Renewable Energy Fair in Custer, Wisconsin, Intersolar in San Francisco in July, and Solar Power International in September in Anaheim this year. Check out the QuickMount PV website for all the webinars on solar roofing products, solar business practices, roofing codes and standards. You can also learn more about the video tutorials and training downloads that we have posted on the website, as well as see a calendar of hands-on training opportunities. I will reiterate that this webinar is available 24 hours a day, 7 days a week for NABCEP credit on demand. You can download the PDFs for the slides at the website, and all the questions that you might have will be answered within 24 hours of submission. Just submit it through the GoToWebinar tool that you have there, and those questions will be answered within 1 business day. You will get 1.5 NABCEP credits for sitting through the entirety of today's training, emailed to you within 1 to 2 weeks with the NABCEP credit certificate and links to download this presentation slides in a PDF file format, as well as view a previously recorded version of this webinar on YouTube if you wanted to repeat some of the material without sitting through the NABCEP certified version of it again. Check your spam filter if you don't find that email within 1 to 2 weeks, and please rate today's content. We do our best to continually improve on the material for future webinars. So I want to thank everybody for their participation and hope that this was of value to you, and look forward to meeting you at some industry event somewhere down the road. Thank you very much. Have a great day.